Hello everyone. In this series of videos, we are going to discuss another application of NLP, which is a spam classifier. You might have seen spam classification in your Gmail inboxes where some of the emails automatically get transferred into your spam section. And you might have seen that those unimportant emails are automatically get transferred. So the logic behind is basically the same as in NLP, how it has some predefined rule set, and accordingly the classifier automatically transfers the unimportant mails or some advertisement into the spam section of your inboxes. And it usually checks for each mail that you get in your inbox basically. And in this tutorial we will also be creating a basic spam classifier, and we will be mainly focusing on the email spam detection. So yeah, let's start. So today we are going to understand about basics of NLP and with the help of the email spam detection dataset. And we see some common NLP tasks that one can perform easily and how one can complete an end-to-end project. Whether you know NLP or not, this videos should help you as a ready reference, you can say. So NLP is the art and science which helps us extract information from the text and use it in our own computations and algorithm. So let's mainly focus on our problem statement. So problem statement is like we are going to create an automated spam detection model. So this will just be a small demonstration. We'll be just creating an automated spam detection model. And during this process, we will mainly be taking around 9 steps in order to make sure how this project is get completed. So the 9 steps is mainly divided into, like, let me just show you the 9 steps. Let me just write it. So the first step that we will be doing is like read the data set and make it in proper format. So basically, pre-processing the data you might include. Another step is basically encoding labels. Okay, let me just write all the steps and I'll explain you. So yeah, these are the 9 steps that we'll be following. So first we'll read the data set and make it in a proper format. So we need to have some pre-processed data which is in good format so that we can pass it into our machine learning model. And then we'll encode labels, and the one step that we'll be doing while processing the data, we'll convert all the cases to the lower, because we want our machine learning not to distinguish between capital letters and small letters. That's why we'll be including converting all the letters into the lowercase. We'll be even removing punctuations and remove stop words. These are the most important functions that we usually perform in any NLP projects. And then we will convert all the text into vectors, and we will import a classifier, and then finally we train and test bits. And last steps, we'll just check the accuracy by just importing some methods, or we will even create a confusion matrix. And then finally we'll generate a classification report. So these are the 9 steps that we'll be taking in order to create a spam classifier. So let's start. So let me just delete the cell. Now let's start coding part. So first step is basically importing the libraries and datasets. So importing necessary libraries is the first step of any project. So when starting an NLP project for the first time, always remember to install an NLTK package and import some useful libraries from this package. So let me just show you. First, you have to import the NLTK. So for in importing NLTK, first time if you are using, so you need to pip install the NLTK. For that, we have to just write pip install NLTK, and you have to shift the center. Let libraries get installed. Okay, now pip NLTK has been installed. Now let's install the important packages. We will be working with the word cloud graphs. As you might have seen, that word cloud graphs is just a graph which is made up of words, and then if a word is occurring most of the times in your vocabulary or dictionary, that particular word will be having a larger font compared to the words which has been occurred very less number of times. And so that word which has occurred less number of times will be having very smaller font. Now for installing word cloud, we just need to do pip install q word cloud. So this should be hyphen. So after installing the word cloud, the next step is basically to import NLTK and import word cloud as well. So for that, word cloud, and we will be importing import NLTK. Now from NLTK, the files that the major package that we want to deal with are the stop words. So NLTK.download, and we have to specify stop words. So just specify like this. This will download all the stop words from the NLTK library. And we also want to download the WordNet library. So we can do like that WordNet, and we will also be dealing with the Punk library. So to specify Punk, take it on download. NLTK. It's correct. Averaged underscore perceptron underscore back. Okay, now let me explain you what are why we have downloaded these 4 files. So basically, as we all know, stop words is a basically list of words which are redundant words and which doesn't impact the much meaning of a sentence. So these are words like to and for and everything. So these words mainly do not contribute to the meaning of a sentence. That's why we need to remove those stop words from the text so that the length of the text will get shortened, and we will be easily train our model on only to those short words, like limited number of words. That's why we have imported stop words. And for WordNet, so this WordNet is a part of the Python's natural language toolkit. So it is the large word database of English nouns, adjectives, adverbs, and verbs. So basically, it is a lexical database of semantic relationships between words in more than 200 languages. So WordNet links words into semantic relations, including synonyms, hyponyms, and paronyms. So we will be using WordNet, and we have for Punk, basically Punk is like for tokenizing module. So Punk sentence tokenizer. So this tokenizer divides a text into list of sentences by using an unsupervised learning algorithm to build a model for abbreviation words and collections and words that start sentence. So Punk will help to deal with those in order to create the sentence tokenizer. And finally, we have used the average perceptron tagger. So basically, Punct is used for tokenizing sentences, and average perceptron tagger is used for tagging words with their parts of speech. Like a word has like a noun, like a ball is there, and it is basically a noun. So this model will help tag that word to that entity which is noun. So that's why we have imported these modules. So now let's run sentence. Okay, so now our libraries have been downloaded. So now it's time to import some basic libraries and important fundamental libraries that we will be dealing with. So we know that one of the most important libraries is Pandas, so we will import it as PD. And we would be needing NumPy for handling the arrays, NP, and we needed matplotlib at best, matplotlib for visualizing purposes, plot as plt, and next we need cbon, sns, and from sklearn dot feature underscore extraction, we will be needing dot text, we need import, we need to import tfidf vector vectorizer. So basically this TF-IDF vectorizer will convert all the raw documents into a TF-IDF vectorizer particular format in a matrix format. That's why we have imported this. From naive bias we need multinomial NB. Quote thing. Oh, sorry, I'm doing this on the same line. Yeah, I'll just cut it. Now let me just copy this and from SK on dot naive bias. First we need spelling is wrong. Okay, this is correct. We need multinomial NB, nomial NP. Now let me just copy again. Now from model selection, basically model code selection, we need to import the train test split, train underscore is it train? Okay, train test split, and finally we need to measure the accuracy. We have to import scalar metrics. We need accuracy score, accuracy underscore score. We need classification report, and we need confusion score metrics. Finally, for our models, from sklearn.svm we need to import SVC. So SVC is basically for support vector machine algorithm for vectorizer vectors basically. And finally, we do not want any warnings, so we can even import warnings, and we want to ignore that warning. So what we can do, warnings dot filter warnings, and we want to ignore if any warnings come, so we have to type like this. And finally, these are the important library that we need, and we will just run it. Okay, tricks. Okay, let me just comment it. So I've just added comments as well in the library, so that you are able to easily understand which piece of code does what and which is required for what. So let me just shift to center. Finally, we have our library is loaded. Now it's time to load the data sets. For data set, we have to just pd.read underscore csv, and I have just uploaded the data file here, message.csv. You can even download it. You can just even upload it in the Jupyter notebook by just clicking this part and just specifying the dataset directory. So just here, so I just need to copy the path. Just copy the path. Finally, we need to shift the center. So the data set has been moved. So before we move on, let's just first check out our data set. So our data set basically looks like this. So as you can see clearly, there is 3 columns: subject, message, label, and each subject has been given with the message, and each entity is separate by a comma. So this is our data set, contains around, I think, 3000 rows. Not sure, let's just check how many rows it contains. So basically this is the data set we are working for. It is just messages of CSV, and you can see the job posting. Apple is research center, this is the subject, and for message you have content slash length is basically this, and finally the label which says that is it a spam or not. So it is not a spam, that's why label has been given to 0. Now let's back to the coding. Now let's just see the data set itself. So for that we have to just head, shift plus enter. Just running. So yeah, as you can see, it's subject, the message, and the label. Now if you want to check some info regarding it, so we as know for checking the info we have to just type df.info, shift plus enter, it will give you the info. So you can see the 3 columns, the each do not contains any empty, that's why non-null. If it would have contained empty, so some values have been given as the empty values, so but it is saying non-null because do not contain any null values. And the data type has all been shown that for the subject and message the data type is basically object, and for the label 0 and 1 it has been considered as integer. Now for checking the rows, so you can for checking the rows, okay, it is contained around 3000 rows. Okay, so I was right. So for checking the shape of the data set, so you can just type print shape of data set and use df dot shape. Sorry. Now you can see 3 on the row with the 3 columns. But I'm not sure that, as you can see, there are 2831 values which are non-null, but and rest contains 2893s. So there might be some null values in the subject. So as I said before, so I was basically wrong there. As I said, they are not null values. So this specify like 2831 entries are non-null, not all the columns, but only the 2831 entries in your entire data set are not. So let's just check if in order to check the null values, we can just simply type df dot is null, and we can sum the values because we want to get the sum for the values. And when I press shift plus enter, okay, so 62 values are null values in the subject column. So 62 rows are missing in the subject columns. That means 62 emails are without subject heading. So here we are not dropping the 9 rows for subject columns as it of no use in building. So we just see. Okay, so now we check the spam and non-spam emails in our data set. So for that, just need to type print. So we just type count of label. Wanting new row, so we need to specify the new line. Comma df dot value underscore counts. So I run it, shift plus enter. So you can see. So here we see that 1 stand for spam mail and 0 stand for non-spam mail. So now let's see. So let's proceed with the checking ratio or percentage of labels, that is spam and non-spam emails, and observe that the details are like what. So we just see that. So now let's check the ratio of the labels for each label. So let's just check for that print not a spam email ratio, that is 0 label, like the values of the 0 label, and the value will be basically using round function. Yeah, in the round function we need to specify the length of df label data set the value should be double equals to 0, and we need to divide by the length df label. Yeah, removing 1 columns, and we want this value to be just rounded off the 2 columns, so we'll specify 2, and outside we want this to be multiplied by 100 star 100, and we want the in the percentage, we'll specify percentage. So this is the logic, and similarly we can use for the label 1. We just need to copy the statement again. So let me just paste the code and show you the final result. Again, I added the comment. Let's shift plus enter. Now you can see not a spam ratio is basically 83%. So excuse me. So we can observe that 17% of the mails are spam emails, and rest 83% are not a spam emails in our data set. Since this video is getting a bit long, so we will continue in the next video. In the next video, we will create a new feature named length to check the length of each message, and we'll convert every alphabet to lowercase in the message. So yeah, let's see you in the next video, guys.